I welcome you all for this today's session in order to discuss the chapter 5 measurement in module 2. In the topics of the module 2 for today's discussions are physical quantities. Here we will learn the definition of physical quantities and the types of the physical quantities, such as the fundamental physical quantities and the derived physical quantities, with the proper example including the units of the physical quantities. The next topic of module 2 is the international standard meter, only general concepts. And the last topic of the module 2 discussion is measurement of different physical quantities and with their useful devices, such as measurement of mass and the device of mass measuring area, volume, time, and the measurement of plant and animal growth. Finally, we will discuss. So let's start today's discussion. I would like to discuss today's discussion from your own book, the page number 97. Here is the first topic is the physical quantity. First we have to know what do we mean by the physical quantity. See, we can measure different quantities by different devices. Anything that can be measured is called a physical quantity. So what is a physical quantity? A physical quantity is something that can be used to measure anything. Clear? Such as, for example, time, physical quantity; mass, physical quantity; weight, physical quantity; length, breadth, height, etc. can be measured. That's why they will be known all as physical quantity of substance. In your book here you will get this is the diagram, and we can easily measure the physical quantity of this diagram, such as the length, the breadth, and the height. Here is the example, such as the density. So first we have to know what is density. Density means mass by volume of any substance. So the formula in order to find out the density of any substance or matter is D equal to mass by volume, or we can also write in this way: M means mass, smaller, by LBH, L for length, B for breadth, and H for height. So this is the density of any substance or material that we can measure easily. Now, what are the types of physical quantities? Physical quantities can be divided into two groups, such as the fundamental physical quantities and the derived physical quantities. So what are the fundamental physical quantities? C. Length, breadth, height, mass, and time. Once again I am repeating: length, breadth, height, mass, and time do not depend on other physical quantities. So these quantities will be known as the fundamental physical quantities. Fundamental physical quantities are those physical quantities which are not dependable on other physical quantities of any substance, such as the length, breadth, height, mass, and time. These 5 physical quantities of any substance will be known as the fundamental physical quantities of any substances. Whereas the derived physical quantities, what is the definition of derived physical quantities? Derived physical quantities mean that will be dependent on other physical quantities, such as the fundamental physical quantities, such as length, breadth, height, mass, and time. Here you can see the density is the fundamental physical quantity or the derived physical quantity. I think density is the example of the derived physical quantity. Why? Because here there are the other physical quantities, such as mass and volume. Clear? So density is an example of derived physical quantity, but not the fundamental physical quantities. Clear? Once again I am repeating, what is derived physical quantity? Derived physical quantities are those physical quantities which will be dependent on the other physical quantities, basically the fundamental physical quantities, such as the length, breadth, mass, and time. Example of the derived physical quantities here is the density. Now I am turning the page. page number 98. Here you will get the unit of different physical quantities. First, we have to know what is the definition of unit. Unit is a standard that is used to measure the physical quantity of any substance. That's it. Once again, I am repeating, what is a unit? Unit is a standard that will be used to measure any physical quantity of any substances, will be known as the unit. I am reading out from your book. In the measurement of physical quantities are, we know, are of two types: fundamental physical quantities or the data physical quantities. Only the numbers value of the measurement have no meaning, such as if I write 5 and if I don't write after 5 any unit, then it will have no meaning. That means it is meaningless. If I write 5 centimeter, then centimeter is the unit of the length. Or if I write the 5 kilogram, then it is the kg is the unit of the mass or weight. Clear? That's why here is the necessity of giving or putting or writing down the unit after the numerical numbers of any physical quantity of any substances. So this is the necessity of using the unit. If we don't use the unit, then it will have no meaning of using the numerical numbers, and it will denote different types of meanings. That's why we have to put or write down a fixed or specific specific unit after the numerical numbers in order to denote the physical quantities specifically of different substances, such as second is the physical unit, second is the unit of the time, such as, and for example we can say others say the kilogram, the centimeter, the meter, the foot, then centimeter per second is square, etc. So in the measurement of physical quantities, if we put only the numerical values of measurement, it will have no meaning. These quantities requires unit. Try to focus your attention. These physical quantities will require units in which they are measured. The measurement without mentioning any unit after the numerical value of the measured quantities are meaningless. I hope this concept is clear. Now here is once again the same repetitive statement of the definition of unit. Unit in a simple language we can say is a standard of physical quantity that will be used to measure the physical quantity of any substance. That's it. Now see, in order to measure the length, this is the physical quantity. In different countries there are different types of concept to measure the length. Very often lengths are measured by common people by their hand spans. So hand spans is the method of measuring the length, and are expressed the measured length by bigha in the India. So in India, bigha is used to measure the length. In ancient Greek, unit bigha of length was hand span. So in the ancient time, in Greek and in other countries, hand spans was used as a unit in order to measure the length, whereas in India bigha was used. Today it is still using also in India, and in Egypt it was called the cubit or the hand. So we are getting here three different types of units of measuring the length. Bigha in India, in ancient Greek the hand span, and also in other countries, and whereas in the case of Egypt the cubit or the hand was used. So these are the unit of length, and was used differently in different countries. Now we have to know the concept of International System of Unit or SI unit. So what is it? In 1916, scientists sat together and accepted universal standards for different units, which will not change in respect of place or country or the person. So this will be known as the International System of Unit or SI units. So what are the SI units of different physical quantities, such as example length unit is meter, mass kilogram, time second, current ampere, intensity of light candela, quantity of atom or molecule mole, and the temperature is Kelvin. You have to know all these units of these physical quantities properly. please focus, try to focus your attention over here. Physical quantities, this is the name of the different physical quantities, and this is the internationally accepted units, names of units. Now I am moving to the page number 99. Now a physical quantity is measured as a multiple of its unit. This is the statement regarding the unit of physical quantity. So any physical quantity of any substance is measured as a multiple of its units. Now this is the important information regarding how should we use the writing of any symbol or any unit using the SI method. So these are the few steps we have to abide by. First, number one is full stops, comma, etc. are not written after the symbols of the unit. So after writing the symbol of any unit after the numerical number, we have to be very careful regarding this, that we should not put any full stops or comma after writing the symbol of the unit. For example, we should write M for meter, not M comma or M full stop. Clear? Second important thing regarding this is the symbols of the units are always used in singular form, not in plural form. Once again I am repeating, symbols of the units are always used in singular form. For example, if we write 1 m, that means to 1 meter, 5 meter, these are all right, but not 5 meters or 5 centimeters. Clear? Because 5 meters or 5 centimeters are in plural forms. The third point of this topic is name of a unit is never written in initial capital letter, even it is named after some person. For example, we have to write ampere, only the letter A should be smaller, not capital. Joule, J smaller. Newton, N smaller, not in capital letter, such as not as ampere, capital letter A, capital letter J, joule, capital letter N for Newton, etc. So we should write not ampere capital letter, but we should write A smaller letter ampere. Another important thing is, if a unit is named after a person, the symbol is written in capital letter. So in this case, we can write the symbol in capital letter if it is named after a person, but the symbols of all other units are never written in capital letters except the names after a person. We cannot write the symbols of other units in capital letters. For example, we can write ampere by using capital letter A, Newton capital letter N only, meter not capital letter M but small letter m, kilogram, such as. In SI, all the bigger or the smaller units of a physical quantity is expressed as multiple or submultiple of 10 of the standard. What are the examples? Such as this is mainly the conversion of the centimeter or meter or centimeter into millimeter. I think we have the knowledge in this is the mathematical calculation. Clear? Conversion of the different units from millimeter to centimeter, centimeter to meter, etc. Such as 10 millimeter equal to 1 centimeter. You can go through it. Very easiest one. Now the next thing is international standard meter. What is an international standard meter? Now see, the length between two marks on the rod is taken as international standard of a meter. So we are talking about here the acceptable rod. What is rod? A cylindrical rod, and it is made of platinum and the iridium, was kept at 0 degrees Celsius temperature in the Institute of International Bureau of Weights and the Measures in the Paris. So we have to consider the cylindrical rod, and we have to also consider the length between two marks on the rod. So on the rod there are 2 marks, and the length between these 2 marks of that rod will be accepted as the 1 meter. So this is the universally accepted standard to find out the meter. Clear? So this will be known as the international standard meter. Now in the page number 100 we will try to measure different physical quantities of substances. First example is the measurement of mass. We know mass is the basic property or basic physical quantity of any substance. So mass can be measured by using a common balance. Clear? So mass is measured by a common balance. This is the example. This is the diagram of common balance. Here you will get 2 types of pens. One pen will be used for weights, another pen will be used for measuring the substance. In a common balance we compare the masses of 2 objects. Once again I am repeating, using a common balance we compare the masses of 2 objects. So in order to measure the mass of any substance we have to use the device common balance, and in the common balance generally we are comparing the 2 different types of masses of 2 different objects, and these 2 different objects are, number 1 is substances, that the mass of that substances is to be measured by taking the help of weights. Now the question is, what is weight or weight? What are the weights? So these are the metallic brass blocks, and these are kept in the ratio 5:2:2:1 in the weight box to measure the mass of any substances. So this ratio 5:2:2:1 is the ratio of the weights, the brass metallic blocks, and using this ratio we can easily measure any kind of mass of any substances. Clear? Now we have to measure the area. So area is another physical quantity of substance. So what is the formula of measuring the area? If I take this example, this is the rectangular figure. So the area of a rectangular means length into breadth, we know. Clear? So in order to measure the rectangular figure, its area will be length into breadth, that's it. Whereas to measure the surface area of a ball, the formula is the surface area of a sphere pi into diameter square. This is the formula, and using this formula we can easily measure the surface area of any ball, but not the rectangular figure. In order to measure the surface area of any rectangular figure or square figure, we can say length into breadth, that's it. But in order to measure the surface area of a ball, we have to take this formula, the surface area of sphere equal to pi into diameter square. So now you see this symbol will be pronounced as pi, and it is the constant, and it will have the value, and the value is 22/7 equal to 3.14. Clear? Now the third case of measuring is the measurement of the volume. First we have to know what does the term volume stands for. Volume is the space occupied by any object. So whenever an object will occupy some space, this space will be known as the volume. Clear? So what is the unit of volume? First we have to know what is the device of using or measuring, sorry, what is the device for measuring the volume? The volume of a liquid is measured with this scale, so we can use cylindrical scale. So the device of the measurement of volume is cylindrical scale. Clear? So the volume of liquid is measured with this scale. Such a cylinder is called a measuring cylinder. So the device of measuring the volume is measuring cylinder, and by taking the help of measuring cylinder we can easily measure the volume of liquid. And the unit of the volume in centimeter in CGS system is the cubic centimeter, whereas in the meter case it is the cubic meter. Clear? Once again I am repeating, what is the volume? Volume is the space occupied by any object, will be known as the volume, and the device that will be used to measure the volume of any substance is the measuring cylinder, and the unit is the either the cubic meter or the cubic centimeter. Now for the measurement of time, so we have to know what is the definition of time. The interval between starting an event and completing it will be known as the time. So time is an interval between starting an event and completing it will be known as the time. For example, the interval between starting from home and reaching the school by a student, the time required by him. Clear? So this is the example of clarifying the concept of time. So time is interval between starting an event and completion of it. That's it. Time cannot be seen. Time cannot be seen. It is intangible, but it can be measured with the help of solar day. So time cannot be seen. It is intangible, but it can be measured with the help of solar day or other devices also. Let's look. So first we have to know what is solar day. The time difference between the first sunlight falling on the ground on a day and the first sunlight falling on the ground on the next day will be known as the solar day. We know throughout the year the length of the solar day are not same, because we know there is the distance of between the sun and the earth, and the distance is differentiated in different times. That's why the solar day, the time of the solar day is not similar. So throughout the year the length of the solar day are not same. So the length of the times of all the 365 days of a year are added, and average solar day is found by dividing the total time by 365. When average solar day is divided by 24, we can get 1 hour. Similarly, dividing 1 hour by 60, we will get 1 minute, and dividing this 1 minute by further by 60, we will get the second. So second, minute and hour are the unit of time. So what are the devices of measuring the time? Clock. Using the clock, wall clock maybe, or the hand watch. So using this kind of devices we can easily measure the time. Let's have a look. Previously we used spring operated wrist watches or the wall clocks or the pendulum clocks in order to measure the time. Now here you will see another type of devices to measure the time, that is the stopwatches. And what is the necessity of using the stopwatches? Mainly these are used in sports events. Clear? Nowadays we can use battery operated electronic watches also. In earlier times, sand bottles were also used to measure the time. There are another types of watch, and that was used in the ancient time, and that was the solar watch. And this solar watch was based on the length and the position of shadow of an indicator formed by the sun rays given time. Such a solar clock is at Jantar Mantar. So if you go or visit Jantar Mantar situated in Delhi, you can have a look the solar watch. So there are different types of devices, once again I am repeating, through which we can easily measure the time. Example, clock or hand watch. There is the using of spring operated wrist watches also, wall clocks also, or pendulum clocks also, stop watches also, and this type of watches are used mainly in the sports events, sand bottles in ancient time, and the solar watch, jantar mantar. You can also see this type of solar watches. Now the last topic of this module 2 is the measurement of the plant and the animal growth. So what is the device? You can see this is the figure of the device of measuring the plant growth, and this device is known as the oxynometer or the ARC oxynometer. The growth of a plant is measured by an instrument, and this will be known as oxynometer or the ARC oxynometer. So by taking the help of oxynometer, we can easily measure the growth of any plant. Here is the formula. What is the rate of growth of plant? So rate means time, so growth by time. Clear? Now see, to measure the weight of a living plant, just we have to use the device, and that will be known as the sensitive balance. So using the sensitive balance, we can easily measure the weight of any living plant. Whereas to measure the animal growth, such as the height, we can use the vertical scale, or it will be known as the centimeter scale. Whereas in order to measure the weight, we can use the weighing machine, and generally it would be known as the unit is kilogram. So this is the in detail discussion of module 2 of different topics. Now after completing or reading or understanding this module 2 topics, you have to do your home assignment. In your book you will see these are the questions, and this done for you. You can easily go through it for your own understanding. Page number 166, there are lots of questions done for you. Now come to the page number 107. Here question number E, F, G, H. You have to answer yourself, and this is your home assignment. After completing this, you can send me at my WhatsApp number. Thanks for watching. Have a nice day.